Alright, today we shall be looking at the Hooke's equation of elasticity, which is coined from the Hooke's Law, named after a scientist called Robert Hooke. Alright, let's go. Now, the Hooke's Law states that provided that the elastic limit is not exceeded, that the force applied in an elastic material is directly proportional to the extension made. This is very simple. If we have a spring, elastic spring of this length, original length, if we apply a force on it, let's say we apply a force on it this way, this spring can end up getting to this point, such that from here to here is the extension made. This is the extension. We have a force F1, extension made is 1. And it says if we increase the force on it, if I have a bigger force than this on it, the spring may end up elongating more up to this extent. That is, from here to here becomes our extension 2 because of a greater force of F2. So in that case, the greater the force, the longer or the higher the extension. So the force applied is proportional to the extension made, in as much as the elastic limit of that material is not exceeded. And of course, if it's exceeded, the law no longer holds, because the material may end up snapping or cutting or breaking. But in as much as the material is still within its elastic limits, the force applied is proportional to the extension. And if we put this mathematically, we can say that the force applied F varies directly as the extension made. Okay, this is just a proportional statement. We can say to change this to an equation by removing this symbol of proportionality and putting up an equation sign. And to do that, we must introduce a constant which we call a constant of proportionality, which in this case is called the stiffness. So F is equal to, take away this and put a constant K E. So where K is a constant called the elastic constant, or is also called the force constant. It's also called the stiffness of the material, yes, which can be derived as K equals F all over E, because we can divide both sides by E here to have that K equals F over E. If F is in Newton and E is in meters, we can say that the dimension, the unit of K is Newton per meter, also written as Nm raised to the power minus 1. So this is the unit for force constant of any material. Alright, see you in our next video. Bye bye.